Good morning, Year 12 single mathematicians. Just going to keep carrying on with Chapter 11, 11.3 Maxima and Minima problems. So we're still on variable acceleration, so lots of curves rather than straight lines. And the main objective today is to apply differentiation to work out maximum and minimum values of displacements, velocities, and accelerations. So there's no actual extra stuff in terms of notes. Just need to remember the stuff we've done last time in terms of differentiating the displacement gives you the velocity, and differentiating the velocity gives you the acceleration. So we will need that, but nothing new. So the first problem is a wordy one. So we've got a child is playing with a yo-yo. The yo-yo leaves the child's hand at time t is equal to 0 and travels vertically in a straight line before returning to the child's hand. The distance s meters of the yo-yo from the child's hand after t seconds is given by that formula there. T is between 0 and 3, and they've asked us to justify the restriction of t being between 0 and 3. Now, what do they mean by that? So they're kind of trying to say that the formula only makes sense between 0 and 3. If you picked a number bigger than 3, the formula would break down, wouldn't make sense in this context. And if you picked a number less than 0, again, it wouldn't make sense. Now, the greater than or equal to 0 one is easier to justify because you can't have a negative time. But being less than or equal to 3, not sure yet. And the one thing I can give you advice on for this is if you drew a sketch of the curve, it might be easier for you to justify. And there's also one word in there which is sticking out for me, which is the fact it's talking about distance. And we've already mentioned that time can't be negative, but distance can't be negative either. So that might be a clue on what's gonna happen with this one. So I'm gonna try and draw a sketch of this. You've drawn cubics before in pure maths, and you're expected to do it in a very specific way. So you do shape. What would the shape of the cubic be? Well, it's a negative cubic, so it's gonna look like this. Second thing you would do is you would do the y-intercept, or s-intercept in this case. When t is 0, put 0 into this, you get s is 0. And then also we're going to do the x-intercept, which is when s is equal to 0. And that would be 0.6t plus 0.4t squared minus 0.2t cubed is equal to 0. Now, many ways you can solve this. Not a massive fan of decimals, so I could times everything by 10. You could actually times everything by 5, and that would get the job done. So I'm going to times everything by 5. And I'm also going to take it to the other side, and you would get t cubed minus 2t squared minus 3t, I think. Yeah, that looks right to me, to get this cubic. And if you solve this cubic, best way to solve a cubic is factorizing t squared minus 2t minus 3. Factorize again, 0, t minus 3, t plus 1. To give you 3 values of t, either t is 0, 3, or negative 1. And then that's enough information for you to draw the sketch. Doesn't have to be a good sketch. It's got to go for 0. It's got to go 3. It's got to go through negative 1. It's got to go through 0 as the y-intercept, and it's got to have this shape. And the only way for you to draw that cubic is like this, and that's what it would look like. Now, does that help us justify? The answer is yes, because in this section there between 0 and 3, that is the only section where the curve is above the x-axis. In other words, positive. When it goes past 3, it goes negative. When it goes past 0 to the left, it's negative as well. So you can, that's your justification. So curve is non-negative between 0 and 3, which is needed for distance, something like that. Okay, I'm wording that as best as I could, but yes, something like that, some reference to distance not being negative. Okay, part B. Find the maximum distance of the yo-yo from the child's hand correct to 3SF. So in maths, when you see the word maximum, one of the first methods that should come into your head is differentiation. Differentiation was invented to work out maximums and minimums, so it's probably going to be useful in this question. And if you look at the sketch I've done above, remember this is t-axis, s-axis, time and displacement. You want the maximum displacement in that green section. And that maximum displacement would be at this peak. Now you don't know if this curve is perfectly symmetrical, so you can't just say in the middle. So we have to differentiate and then make equal to 0. So let's do that. ds by dt. Differentiate that formula back up there. It'd go to 0.6 plus 0.8 t minus 0.6 t squared. And then the maximum would occur when this is equal to 0. So you make it equal to 0. Which kind of does make sense, because remember ds by dt is also equal to the velocity. And if you were playing with a yo-yo and you were letting it go up and down or whatever, then the further it gets away from you, its velocity would be 0. So this all does make sense. This is quadratic, don't like decimals, so I'm going to get rid of them. You can just times by 10, or in this case times in by 5 would be good enough. But I'm going to take everything to the other side as well. So that would be 3t squared minus 4t minus 3. And then you've got this quadratic. You can use the quadratic formula for this. I'm just going to use a quick product and sum. Product needs to be minus 9. Sum needs to be minus 4. Doesn't work. Should have clocked that because it says correct to 3SF. So we'll use the formula. T is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And then I'm going to cheat actually. Use the equation button on the calculator. 3 minus 4 minus 3. Get a t-value of 1.86851 dot dot dot, or negative 0.53518 dot dot dot. And I'm going to discount the negative time because it's got to be between 0 and 3. And that's the time that this maximum distance is achieved, but they want you to find out that actual distance itself. So how can you find out the corresponding distance? Well, you substitute it into the formula for distance. Should be pretty obvious. Okay, so S would be equal to, so replace every single t value back in that formula with that new time. So 0.6, 1.865, 8685, sorry, 1 dot dot dots, plus 0.4, 1.8685, 1 dot 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 squareds, minus 0.2, 1.865 dot 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 cubes. Wondering if I can store that on my calculator. No. Okay, go back to that. So it's 1.86851. So 0.6 lots of that, plus 0.4 lots of that squared, subtract 0.2 lots of that cubed, should be the maximum distance, which is 1.21 to 3SF meters. That does make sense. It'd be a very long string on the yo-yo if it was more than 1.21 meters, and then that would be it. So not sure if you actually saw that last bit, but yeah, that would be it. So 1.21 meters for that, and that's it. That's the end. That's the only example I'm going to do. If you find exercise 11C, which is on page 187, I'd like you to try questions 2, 3, 4, and 5. And again, if you're struggling with any of these questions, then let me know. Remember to upload your workings to the class notebook, and I will see you soon.